This you'll need if you are starting your career. If you are in high school or in college, come and hear the skills, the roles and goals you need to know to keep yourself focused. Best believe it, you gon' need it. Career Focus. Career Focus.
Hello everybody and welcome to a new episode of Career Focus, part of Inflation Future. I'm your host Alexander Marinov. Today I have as my guest Elie Kawerk, PhD in computational physics, and currently he's a senior data scientist in a very large online retailer. Hi Elie.
Hi. Thank you for having me.
No, thank you for taking the time. So can you give us a brief overview about yourself?
Definitely. So originally I studied physics, did a bachelor, a master's, then a PhD. So during my PhD, I've worked on atomic molecular physics, which essentially consisted of simulating molecules, atoms, interactions with X-rays. So I used a lot of quantum mechanics to interpret experimental data. After that, I have done a postdoctoral research fellowship in Italy for 1 year. So this is my background, more or less. I'm going to talk a bit more later how I transitioned into data science during the interview also.
Thank you very much for the introduction. So obviously, once you're in high school, finishing high school, not everybody knows what they want to do. How did you decide to go into the physics route? Did you knew that immediately, or did you just came about it, or how did it happen?
So yeah, when I was in high school, we had a very good physics teacher, made me love the subject. So I wasn't thinking a lot long term. So I thought that like a career in academia, like becoming a professor would be good. So back then, honestly, like I loved the subject, so I went to it. And yeah, like this progressed into a master's, like in-depth studies of a specific topic, which is physics. And yeah, this was how I got into it.
And obviously, after your master's degree, you went straight into a PhD. And how did you find the whole experience? Obviously, because after your PhD, you did a postdoc as well, which is very difficult, as you know. Most people don't, but I know that it's quite difficult to find postdoc after your PhD. So how did you find the whole process?
Like the bachelor's and the master's was quite good because you are in an environment which is kind of more or less structured. You know what to expect. When I went into my PhD, like, when you do a PhD, the subject would be, probably untapped. There would be some research about it, but then you're trying to discover new phenomena or like interpret a new observation and so on. So I struggled a bit, like everyone, no? But I was lucky enough to have like a good supervisor, which kind of supported me. But to be quite honest, like there was a lot of perseverance, a lot of grit. So sometimes things don't work. Sometimes you'll be frustrated because you don't know this technique or that technique. So I had to learn a lot of things myself. And after that, during the postdoc, of course, like after, it's kind of tricky because during your PhD, you become so specialized in one topic. And usually in a postdoc position, it's kind of a temporary contract. You have to jump into a new topic and adapt quickly. So I'd argue that like the skills that I gained mostly from academia is like having grit and trying new things, even if I don't know the topic in depth. So I'd be able to navigate it properly and kind of find my way through.
No, that's very true. And obviously during your PhD and obviously your postdoc, somehow you became interested in data science because obviously now you're a senior data scientist. So can you tell us about that?
Yeah, so it was not an easy transition because during my postdoc, I realized like that the path in academia was quite long and that nothing is guaranteed. And I was kind of right in some way. A lot of my friends who went into like a couple of years of postdoc quit after that. So I was told by a friend of mine, like, why not transition into data science? Back then, I didn't hear, like it was 2015, 14, 15. It wasn't as known as it is right now. there weren't so many resources. So what I've done is that I started exploring, but not seriously. And in the meanwhile, I got a job as a curriculum developer in a chain of schools called Sabis. It's a Lebanese chain of schools, but they have schools everywhere. So I was developing curricula and books for them in physics. Spent almost 2 years and a half in that chain. And meanwhile, I started to exploring how can I, like, what skills do I need to acquire in order to transition into data science? Mainly because, like, I thought that I had like valuable analytical skills that could be used in business. So it was kind of like trial and error, taking a lot of courses online, reading books, reaching out to people, seeing what the market needs. And I landed on my first position like in 2018 in an agency called Miram in Lebanon. So we've done a lot of consulting, mainly for the GCC, the Gulf regions. And then after that, like, unfortunately, the situation in Lebanon was started to get worse. So I'm from there, by the way. And I relocated to Dubai for a few years, worked in a couple of companies ranging from bricks and mortar to e-commerce to quick commerce. So over there, I acquired a lot of the core skills that I use day to day. And recently, I relocated also to Germany. I'm working in a big e-commerce player here.
So obviously, data science is quite vast in terms of topic and scale. You have anything from natural language processing. You have everything from time series analysis. It's a very wide scope, right? Because it's a whole new field. Well, it's not new because it touches upon machine learning, statistics. Which area you would say you're specializing in data science, or you use a lot of different areas at the same time?
Yeah, this is quite tricky. So I would argue that there's a set of core skills that are common to whatever field you want to work in. And these core skills would be, I would argue, programming, especially in SQL and some language like Python or R. Usually it's Python, that's more common. There's like the statistical reasoning. How do you reason about statistics, about experiments, about A/B testing? And of course, like, you have to know some machine learning, like essentially, especially like the core models like logistic regression, random forests, XGBoost. Some deep learning would be good, but not necessarily. It depends on the company that you work for and the field that you're trying to get into. And of course, like, you need to have like good communication skills and understand, like, have a thorough understanding of the business problem that you're trying to solve. So these, I would argue, are the core skills. Now, for me, so I was in a region, I worked mostly in a region where like data science is quite new. So I would say, like, I wasn't doing the most fancy stuff there. So you need to kind of be a jack of all trades because there's less specialization compared to like Europe or the US. So we worked on data pipelines, like partly analytics or data engineer, like using Airflow, but we also developed models for marketing. I've worked also a lot on experimentation, especially in my last role before I relocated to Berlin. So I would argue, like, I had exposure to multiple techniques, and partly data scientist, partly data engineer, partly analytics specialist. So yeah.
No, that's what I've seen is quite common to your experience, because sometimes the company doesn't have the resources to hire a data engineer, a data analyst, and a data scientist, and they just get a data scientist and ask them to do everything, like you said, the jack of all trades. But then, yes, you learn a little bit about everything, but it can be very, very time consuming because you have to navigate all these different areas at the same time. Am I correct?
Yeah, exactly. Like once, but I would argue that at some point it's beneficial because you get to understand like the whole end-to-end process. It's time consuming, that's true. But like, if I haven't went through all of this, like in big companies, you'd be super specialized and they would have frameworks for everything. So you'd use stuff, but not necessarily knowing like why is it used this way or that way. So I would argue that at some certain point, like especially in the start of your career, it's good to get exposure, to the whole end-to-end process. But at some point when you become like senior enough, like it's good to specialize and kind of focus on one subject.
No, that's very true. I think also one thing to point out is that sometimes, especially within data science, sometimes they'll just bring you in and say, we want to, let's say, increase sales by 5%, but they don't know what's driving sales. So they just give you a ton of data and ask you, can you please analyze it for us? And sometimes, because like you said, you're not a subject matter expert on the subject, you won't necessarily know what you're looking for. And then you have to do some research, and it can get very, very detailed, even if you're not a subject matter expert in certain areas, right?
Yeah, of course, like whatever problem is one tackling, it's always good to think about the objective and kind of be clear on what you're doing. Of course, like to be clear, you need to go through a phase of collecting requirements, and even probably before that, observing like how this business system works, what drives sales. You try to go and talk to people who are closer to the ground, try to understand like their reasoning and so on. And then it wouldn't make sense to look at all the data, no? So you'd want to look at data that kind of like supports your hypotheses, So first I would argue you observe, then you hypothesize, then you go look for data, not like torturing the data to fit your hypothesis, but rather the opposite. And based on that, probably you can make some progress and iterate like as fast as possible.
And is it right to say that the most difficult part of a data scientist's job is not only building the models, but also presenting the results? Because obviously in a wider company, not everybody is a technical expert. They might also not be expert on the data, but you still need to tell a good story.
Yeah, definitely. Like I would argue like that the model building part would make up, maybe depends on the company, but it probably wouldn't make up more than 20 to 30%, if I'm optimistic. So, and a lot of the time also, like you might be presented like a vague problem, no? So you'd want to see, okay, you go explore the data, you'd want to talk to people and kind of convince them to buy in for a certain solution. Like, why use machine learning and not a rule-based model, no? So you need to tie any technical metric with any model or whatever rule that you find based on the data to financial metrics, and try to show like the relevant stakeholders how your model or your system, the system that you're creating, is going to help them achieve an objective. And of course, this necessarily needs like good communication.
And obviously, on the project side, which one do you think is better when you have a clearly defined problem, but you don't have the data, or you have the data and then ask you to find a solution for something? Which one do you think is better, or it depends?
It's tough. Like probably you would go through both situations. But of course, like having a clearly defined problem is gonna make it easier for you to iterate, no? However, even if you don't have the data, because what you would do is that you would hypothesize like the data that you would need and then iterate. But of course, like even if you have a good understanding in the first phases, like maybe this is more of an illusion, no? Because you know what you know, but you don't know what you don't know as well, no? And sometimes you know what you don't know. So the most important thing is to have like an iterative process. I would say like it's always kind of on a scale, like it's never that you will never have data. I mean, probably in mature organization, at least, you would have some data, you would have some definition of the problem. But yeah, on a scale from 0 to 1, you have to define like how clear is the problem, how good is the data, because having data is not enough. You need to make sure that it's high quality at the granular level that you need. Sometimes like it's not at the granular level that you need. What would you do? No, is it well governed? Does it reflect the process that you're trying to measure, and so on?
No, that's very interesting. Yeah, I mean, obviously, like you correctly pointed out, sometimes even if you have a correctly defined problem, you might not have the right data. So you have to find the right data, or you have to ask the experts what they think is useful to know, or the other way, you have tons of data, but you don't know what you're trying to solve. So it takes time to sift through different data sets and find out what you're actually trying to solve as well.
Yeah, and of course, also there's one other thing to mention is like not all data is created the same. Not all data has the same value. Observational data is less valuable than experimental data. Why is that? Because when you have observational data, you're trying to model a system, but you don't have control over the interventions. And there might be multiple sources of bias when you're trying to build a model or analyze the data. Some observables that you cannot control, no? On the other hand, when you have an experiment that's set up, you try to randomize, and randomization kind of like kills off any potential sources of bias, of course, if it's done properly. And this data has higher value than observational data. Of course, you can rely on this data to build more robust models, causal models, and not only models that rely on correlations.
No, exactly, because correlation doesn't mean causation, right? This is what a lot of people say, oh, it's correlated, it has to mean something, and you have to explain to them, no. That's because something is correlated doesn't mean it's actually the impact.
Yeah, just a simple example on that, like I've read that in a book, someplace in the US, they measured that the crime rate is highly correlated to the number of police deployed in a certain region. This is counterintuitive, no?
Yeah.
Then if you look at it, like if you build a causal graph, like you know that past crime rate affects future crime rates, but also past crime rate affects like the number of police deployed, no, in a certain region. And this past crime rate affects the laws that are, in that region. And then this affects also the number of police deployed. And the laws themselves also affect like the psychology of burglaries, no? And then this is going to affect also the crime rate again. So you'd have multiple paths of dependence between the number of police deployed and the crime rate in a given region. So that's the importance of understanding the problem. When you understand the problem, you'd be able to map it in a causal structure and then work on the causal structure and try to eliminate any source of bias.
That's perfectly understandable. And obviously, because you worked on so many different projects, sometimes you have to work with many different stakeholders. How is it to manage or navigate the team structure? Do you find it easy, or it was initially hard and then you adjusted?
Yeah, it has been trial and error. So it depends on who you're working with. So if you're acting as a tech lead, you have to deal with more junior people, create a path for them, and try to show how their work, brings value. On the other hand, if you're working with a product manager, you need to align and see how the model that you're developing or the experiment is gonna, help improve user experience or achieve a certain objective on the product level. When you're talking to business people, you need to tie your work into how this is gonna bring value, because this is usually what they care about. So yeah, every kind of stakeholder needs a different way of communication. Like you need to kind of adapt the way you communicate your work to the audience, because you have different personas that you're trying to deal with. And as you get more seniors, you need to be able to kind of, tie like these way of communication.
Exactly. So you need to adjust your way of communicating depending on the audience member, but also adjusting in terms of how do you present it and how you explain things. Yeah,
exactly. And of course, whomever you're presenting to, always make sure that your messaging is simple, is like easy to follow, that you have a flow in your presentation or in the document that you're writing. That's the most essential thing.
Mm-hmm. No, that makes perfect sense. And obviously, you mentioned that technology plays a key part in the data science world. You mentioned some Airflow, you mentioned Python. What about, let's say, the cloud? Are you cloud agnostic, or it depends on the problem? Because obviously you have many different players in that. You have Amazon, you have Google, you have Azure from Microsoft. Also you have Salesforce, and you have Databricks, another area as well.
Like, I mean, I got used to Amazon. I would argue that I've worked in companies also that use GCP, not Azure, Databricks, yes. But in my opinion, like, they're more or less, most of these cloud providers provide like similar services, no? So they would be probably packaged differently, but the essential components are storage and compute, no? And you have to know like which tool to use. Maybe, there are lots of guides online that map AWS services to GCP, to Databricks, to whatever. So I would say that, I mean, maybe one can start with one of these cloud providers probably it's going to be AWS because it's the most, it has the biggest market share. And once you get used to the components, which like, well, what I mean by components is like the core functionalities supported by each component. Like, let's say, for example, Lambda, no? Lambda is like serverless computing. So one can build a few projects with like AWS, for example, or GCP, and then learn a new provider in case like a new employer or their employer changes the cloud provider. I think like there's little difference between these providers. Of course, some of them make it maybe easier for you to execute particular tasks. Like Databricks, for example, is good if you want to run Spark. It's easier to manage things because they do it under the hood for you. But overall, I would argue that more or less most of the cloud providers provide like a similar functionalities.
Yes, just in a different framework, obviously, because of the different products. Yeah. And how do you see all these, let's say, obviously this year is 2023, and at the beginning of this year, we had a very big noise from very famous OpenChatGPT. Now, other companies are launching their own products. What is your view of OpenChatGPT? Do you think it's gonna basically remove all basic junior data analysts, data scientists from the field, and then it's gonna be only seniors left, or how do you see the technology being used or deployed?
No, I don't think so. Like it's a good tool, but at the end of the day, like if you study a bit of NLP, all of what it's doing consists of like computing probabilities, no? So it doesn't have reasoning skills. And you could try this small example, like if you go and ask it like, who is older, me or my older sister? It's going to tell you like that I don't have enough information to make a judgment and so on. So the reasoning skills are not there, no? And if you test it for spatial reasoning or any kind of reasoning skills, a lot of times like it has a hard time. So and let's not forget that developers or whatever you're doing in technology, the first thing that I mean, before writing code, you're trying to understand the problem. You're trying to understand how to map the problem into code and first like create these abstraction layers and so on. Another example, like also, like if you go and ask ChatGPT, I have a Python list, write me some code that would reverse the list and give me or return back the first element. So any junior developer would know how to do it like in O of one time probably or OFN. So ChatGPT will probably reverse it and then because it doesn't have symbolic logic in it, no? Again, like these are a few examples. Maybe they would improve with time, but like all of these roles that have all of the roles related to development, to data science, need reasoning skills, need like to understand the problem in depth and try to map it into like code at the end, no? And at the end of the day, like ChatGPT could be an assistant that helps them a bit, but fully, I mean, if I was a business, I wouldn't rely fully on ChatGPT because that's a bit risky.
Yes, because I've also tried it myself. For simple statements, it's fine. Simple coding questions, it's fine as well. But the moment you correctly pointed out, when you're trying to ask it like numerical reasoning or any sort of reasoning questions, it can't do it because it doesn't have that capacity. It's more like, I would call it like dictionary for data aggregation. You basically put the keywords, and then based on your keywords, it would give you something that's very similar to what you asked it to do. Because obviously it has so much information, it's basically used our variable data up to 2020 as far as I know, on the date released to the public. Obviously they have a more advanced version coming in, but it can't reason at the moment, which is a very big downside, because let's say you're writing something and you have to check it always.
Yeah, exactly. Like the reasoning skills and knowledge skills like are not there, and like integrating knowledge and reasoning is a big thing. Maybe when they integrate these two capabilities, we'll have another discussion. But to date, like I think it's quite risky to rely on ChatGPT, especially for where in decisions where you have high stakes. Probably for low stakes decision, it's okay. But yeah.
Exactly. And now we go to some people have told me the fun part of the podcast, because then they know a little bit about the people I'm interviewing. So can you tell me, what do you like to do in your spare time? Do you have any hobbies?
Well, I like reading. Not the fiction. I read nonfiction. I work out a bit. Recently I started sketching. So yeah, these are my main hobbies.
And do you have any favorite book? It can be in physics or anything else.
Favorite book? Not necessarily like one book, but there are quite a few books that I liked. Recently I read, like, not recently, maybe 2 years ago, I read two nice books. One of them is Ultra Learning by Scott Young. So he teaches like the skill of learning how to learn. Like how to structure a project, how do you reason about your learning. And there's another book called Atomic Habits. I liked it also quite a bit. So it's by James Clear, if I'm not mistaken. And it's about like how do you build like habits that, slowly, little by little, incrementally. How do you create an environment that allows you to have good habits and so on.
And do you have a favorite physicist?
Favorite physicists I do have, like Richard Feynman.
I was gonna say the same. Yeah.
So, he's a Nobel Prize winner. So he worked on quantum electrodynamics. Now, maybe a lot of the audience wouldn't be familiar with that, but essentially it's like a quantum theory describing the interaction of light and matter. So he's quite famous. He has a lot of videos on YouTube. Like he has also a set of lectures in Caltech. So he simplifies like a lot of phenomena in physics to people who are not familiar with physics, and he's like charming when he lectures.
And he also has a book where he details even his work when he worked on the atomic bomb project, the Manhattan Project as well. His time there, obviously, because he met other famous physicists there as well, and it goes through his life story as well, how he got started, how he went, as you mentioned, to Caltech as well. And it's very interesting and inspiring. Yeah.
He's inspiring. I think everyone should, at least if they cannot read his books or his lectures, watch him on YouTube, a few of his lectures.
Exactly. And what are your top 3 apps outside of work?
Outside of work, I mean, it's kind of tricky because some of them I use in my work. So one of them is Notion. I don't know if you heard of it.
No, I'm not familiar with Notion. What does it do?
It's an app that allows you to take notes, but it's you can create databases in it, and it's kind of very interactive. So you create blocks and you can drag them. So this is one of my favorite apps. One other app that I use also is Fitify. It's like a workout app. It structures exercises for you and kind of provides recommendations and so on. And the third app that I use also almost daily is an app called TickTick. So it's a to-do list app. I I kind of organize my day based on it. Like you can kind of also drag and drop on a calendar. It has reminders and so on. So I find it quite handy.
Very interesting. And I have two final questions. So my question is, where do you see yourself in 10 years' time?
Yeah, it's tough to predict. Like if you would have asked me this question 10 years ago, I would have said like maybe a professor or in academia. So maybe I would see myself having a role in product management related to data. So partly like tech lead or individual contributor. Still not sure. I'm seeing where the field is going to go. But I feel like, there's a lack of individuals who can connect strategy work to data science work. Because at the end of the day, like without a strategy, any model that you build like may not be used or adopted. And whatever, if it's a model, if it's data, if it's analytics, like it needs to have like a strong strategy component so that like any company that you work for, whether it's a startup or a big enterprise, like uses or values your work and adopts it.
No, I think that's very true, because you want to see, like, it's not just building models. You want to see the model utilized, right? You want to know what's going to be at the end of it. Is it going to drive sales? Is it going to drive growth? What's going to be used for as well? And you're right that some companies lack that capacity to just go to data and build something. They go to another build something else, then they deploy two different things to see which one works. It's like almost like finger in the air, see what happens. But that's not always the best case scenario, right? You need to have reasoning why you're building something.
Yeah, exactly. Like you need to be focus on the iterative nature, focus on learning. How can you really improve a system that you build? Unfortunately, like if you look at, let's say, Deloitte papers on the subject, you see like that most companies fail in their data projects or machine learning projects.
That's true.
For different reasons, but some of them are related to data quality, some of them related to, I don't know, like lack of talent, some of them is related to lack of business understanding and so on.
Exactly. Yes, that's very true. And my final question is, if you could go back in time to speak to your younger self when you were like 18, just finishing high school, what advice would you give to your younger self?
I would say probably I would recommend looking long-term more than short-term. Like whatever endeavor that you're trying to take, think long-term. So if you want to go into data science, first make sure that you like the field, make sure that on the long term it's something sustainable and it's not a hype like, that's going to disappear in a few years. Look not only at like the publicity around the subject, but go in depth to see if that subject is really providing value, and that if you're gonna go into it, that it's sustainable on the long run.
No, I think that's a very good advice, because data science is quite vast. There's a lot of different fields to explore, but obviously it's a very interesting at the same time because you can get involved in very different areas at the same time.
Yeah, true. And for example, like if you take data science right now, like and you focus only on for juniors, if they focus only on model building, maybe that's a skill that's going to be automated soon, no? And some of that is partly automated. So if you look at the long term, what's not going to be easily automated, at least, is like, how do you strategize? How do you ensure that your work is providing value for the business? All of these nuances that are hard, this irreducible complexity, like you need to focus on improving your skills at that point, instead of like focusing on stuff that's either right now partially automated or that's going to be automated very soon in the future.
Very interesting. Exactly. And on this note, I would like to thank Elie for taking the time, giving us a bit of a taste about what it's like to work in data science, obviously explaining how vast the field is. Very, very interesting discussion as well. And thank you again for the time.
Thank you, Alex.
Thank you. Thank you very much. And thank you to our listeners. And I hope to catch you on our next episode. Thank you.